Cryosleep is one of science fiction's most tempting promises. They make it look easy. You just close your eyes and wake up light years away in a new star system. We've seen it in Alien, Interstellar, 2001: A Space Odyssey, Passengers, and Avatar, to name just a few. It's the perfect shortcut across space and time. But have you ever asked yourself if it's even possible? We're breaking down the 7 biggest barriers between us and true suspended animation, or cryosleep. And the truth is much harsher and even more fascinating than Hollywood ever admits. I'm Danny Alex. Let's explore cryosleep.
Imagine stepping into a small, sterile chamber, a cryopod, as the air turns freezing cold around you. Your heartbeat begins to slow, the lights dim, and you close your eyes. Then you wake up, feeling as though you just fell asleep. But in reality, decades have passed. Cryosleep is one of science fiction's most seductive promises. It turns impossible distances into manageable schedules and makes interstellar travel feel almost routine. But the actual truth about cryosleep isn't so simple. There are 7 major problems preventing us of ever realizing the dream of cryosleep. 1. The cryopreservation problem, the deadly ice barrier. The first and most devastating barrier is ice. The main villain is water. We are basically walking sacks of H2O. At cryogenic temperatures, the water inside our cells freezes and expands, forming sharp ice crystals that shred our cell membranes. This isn't a small minor injury, it's total cellular destruction. The brain, with its delicate architecture and densely packed networks, would suffer catastrophic damage. It will utterly destroy every cell in your body. And there doesn't seem to be any way we can solve this problem. 2. The cryopreservation problem, toxicity and thawing. The proposed scientific workaround for ice, called vitrification, runs into another problem, just as lethal: toxicity. The idea is to replace water with special antifreeze chemicals so the tissue turns into a glass-like solid instead of forming ice. On paper, it sounds elegant. In reality, the concentrations needed to protect large organs like the brain are simply poison. The very substance meant to save the cells can kill them. And even if you somehow balance that perfectly, rewarming is its own trap. Large organs don't heat evenly. Tiny temperature differences create stress that can crack tissues like glass. To pull this off at scale, you'd need hyper-precise control of both chemistry and temperature, something that might require advanced AI systems just to manage in real time. The margin for error is razor thin. One small mistake or miscalculation results in death. It's that simple. 3. The torpor problem, missing biological switches. Because deep freeze is so destructive to human biology, scientists are more interested in the softer version of this concept, a form of hibernation called torpor. This is closer to controlled hibernation than true cryosleep. You cool the body by a few degrees, drop the metabolism, and slow everything down. But humans are not natural hibernators. We don't have the internal switches that bears or ground squirrels use to slide in and out of long sleep cycles without wrecking their organs. We don't know how to safely keep a human in that state for months, let alone years, without the risk of death escalating over time. Researchers are hunting for the exact biological triggers that could safely turn torpor on and off. That search leans heavily on AI-driven drug discovery and genomic sequencing, trying to copy the genetic code that lets these animals shut down safely for long stretches of sleep. The deeper and longer you push that sleep, the more fragile the biological system becomes. 4. The microgravity problem, atrophy and fragility. Even if Torpor becomes medically reliable on Earth, space adds its own cruelty. Long periods of inactivity in microgravity accelerates muscle loss, bone loss, and cardiovascular decline. Blood clots become more likely. A crew could survive the sleep and still wake up, physically ruined. To fight this, you'd need autonomous robotic caretakers that can check each crew member during short wake cycles, deliver drugs, and even perform automated physical therapy while they're still mostly unconscious. Bodies are built for movement, to fight gravity, and to repair themselves through physical activity. Deprive the human body of that for too long, and you don't wake up like it's an afternoon nap. You wake up weak and unable to move. Your muscles have atrophied, and it may be weeks before you are even able to walk. 5. The problem of oversight, a 100% dependence on AI life support. Even if the biology somehow works, the mission still fails if nobody is left to guard the sleepers. A human crew can't stay awake for decades just to babysit cryochambers, but they also can't all be asleep with nobody watching the ship. That means interstellar travel quietly demands a new kind of crew member, an AI life support pilot. This system would have to manage power, monitor every chamber, detect tiny hardware failures, correct software glitches, and perform critical repairs, possibly for years in total isolation. The survival of the entire mission would rest on a synthetic mind that has an enormous amount of time and autonomy to drift, bug out, or quietly decide that its priorities are more important than the human's original plan. 6. The memory problem, the neural backup risk. Even if your body survives years in deep hibernation or cryosleep, what about your mind? Long-term changes to the brain's chemistry, structure, or electrical patterns could scramble memory in ways we don't fully understand. To protect against that, a serious mission might demand continuous neural backups, high-resolution scans of your brain's state and your memories, uploaded to the ship's computers before you ever climb into the pod. On paper, that sounds like smart redundancy. In practice, it raises a disturbing question. If something goes wrong and the AI has to rebuild your mind from stored backup data, are you the same person who went to sleep, who thinks they are you? You might step into the chamber as one individual and wake up not entirely sure that you're still the original. 7. The risks of deep space, the radiation, critical failure, and ethics problem. There are other serious problems that are 100% lethal. Radiation doesn't stop just because you're unconscious. Cosmic rays keep punching through DNA, slowly raising cancer risks or causing subtle damage over years. Mechanical failures become deadlier when nobody can wake up quickly to troubleshoot them, and the ethics of testing multi-month or multi-year human torpor are brutal. How many volunteers are you willing to risk? What happens if they don't wake up right? Who signs off on that experiment? Even if the science races ahead, laws, regulators, and basic human morality will slam on the brakes. Put all of that together, and the fantasy starts to look less like a near-future breakthrough and more like a distant, uncertain gamble. Short to medium term, human hibernation-induced cycles will require significant real-time medical oversight, as well as enhanced biological engineering technology that is flawless 100% of the time. The universe may be waiting, but our biology is still the gatekeeper. And the next great leap into deep space will most likely not be inside a miracle cryosleep pod. It will be the slow, arduous work of learning about our human biology and discovering how to protect our bodies from years of sleep or hibernation to survive the long, brutal darkness of space.
Well, I hope you guys enjoyed the video as much as I did making it. Please like and subscribe. It helps the channel a lot, and I would really appreciate it. If you want to watch more Dimension Zero videos, there's 2 on the screen right now to choose from, or you can go to our channel page, which has dozens more, and I will see you in our next video. Cheers.